In this video, we're going to be talking about the multiplying two or more radical terms. So it's important to note that we have that product rule of radicals that says if I have two radicals being multiplied together, we can bring them together under the same radical. That's still true, and now we just have to make sure we're keeping track of what is under a radical and what is not under a radical. In these first two examples here, we are multiplying by a single term, one radical. So we're going to distribute that radical into the parentheses. So the square root of 3 times the square root of 5, we use that property and we can bring it together. Square root of 3 times 5 is square root of 15. A positive square root of 3 times a negative square root of x will end up negative square root of 3x. We check to see if there's anything we can simplify, and there's no reducing of the radicals, there's no like radicals. That's as far as you can go. Same thing with the next example. I'm distributing one term, square root of w, into that parenthesis. Now you have to be careful with this one, especially this first square root of w times square root of w. Sometimes I see students say square root of w times square root of w is just square root of w, but you have to actually multiply w times w and get w squared, which we will be able to simplify in a moment. Then I have square root of w times negative 7 square root of 5. So that 7 is not under radical. It stays outside. The two radicals are square root of w times the square root of 5, and we can multiply them together. 5 times w is just 5w. And then lastly, I have to simplify any radicals I can and look for like terms. Well, the square root of w squared is just w. Oops, square root of 5w. And those are not like terms, so that's as far as we can go. Alright, what if I have more than one term being multiplied? So in this case, I have two terms being multiplied by two terms. Well, you have one of two ways. You could FOIL, so if you like that method, first, outer, inner, last, that works on 2 by 2. Or if you liked the box method, previously used, we could use that. Again, I'm a visual person, so I kind of like that box method. If there's an empty box, then I haven't multiplied something. So I'm writing 8 and positive square root of 5 on the left-hand side, and then 6 and a negative square root 2 on the top. Doesn't matter which one's which. We multiply 8 times 6 and get 48. We multiply 8 times the negative square root of 2. 8 is not under a radical, 2 is, so they have to stay separated. So we take 8 times the negative 1 and get negative 8 square root 2. 8 was outside, stays outside, 2 is underneath, stays underneath. Now we have 6 times the square root of 5. Same idea. The 6 is not under radical, the 5 is. So all we can do is say 6 times the square root of 5. Lastly, we have square root of 5 times a negative square root of 2. So a positive times a negative is going to end up negative. And then they are both under the radical, so 5 times 2 is 10. Now we rewrite it. 48 minus 8 square root 2 plus 6 square root 5 minus square root of 10. None of those radicals can be simplified. None of them are like. This is as far as we can go. Why don't you try the 3 on the right-hand side? Alright, we have 2 times the square root of 2y. That is one term. There's no plus and minus in there. And we are going to distribute it into our parentheses, making sure that every term inside the parentheses gets that 2 times the square root of 2y. Alright, we have 2 square root of 2y times 10 square root of 10y. The 2 is outside the radical, it stays outside. And then on the inside we have 2y times 10y, which would be 20y squared. We do the same thing with the second term. Now we have 2 times a negative 6. Those are outside the radical. We can multiply them. 2 times negative 6 is negative 12. Underneath the radicals, we have 2y times 3, which would be 6y. And now we need to simplify what we have, so that 20, we can factor 20 into 2 times 10, and 10 is 2 times 5. So we can take out that set of 2's. We already have a 2 out front, so there's a 2 out front, and we take out a 2 when we take the square root. And we can also take the square root of y squared. So square root of y squared is just y. What's left underneath that radical is a 5. And 6y cannot be simplified any further, so we end up with 4y square root of 5 minus 12 square root of 6y. And that's as far as we can go because there are no like radicals. We're going to do the same thing here with this cube root. So again, pay attention to what it is you're multiplying. I have 5 times the cube root of 4y. I'm going to first multiply it by the cube root of 2y squared. That 5 is outside the radical, stays outside. We have a cube root, and 4y times 2y squared is 8y cubed. 4 times 2 is 8, y times y squared. That's going to be minus, again, that 5 stays outside, it's getting distributed also. And we'll have a cube root of 4y times 18y. 4 times 18 is 72, and y times y is y squared. Okay, we need to simplify these. We are looking for cubes, right? Triplets when we factor. Well, 8 is a perfect cube. We've learned that in previous videos. So we have this 5. The cube root of 8 is 2, because 2 times 2 times 2 would give me 8. The cube root of y cubed is just y. The cube and the cube root undo each other. In the second term, we have that 5 still out front. And then we have to factor 72. 72 is 8 times 9. And 8 is a perfect cube. So we're going to have a set of 2's we can take out. 9 is not a perfect cube. There's only 2 3's. So the cube root of 2 cubed is 2. Take out the set of 3 2's. And then what's left underneath the radical, we have 3 times 3, which is 9, and a y squared. Right? We're not looking for squares now, we're looking for cubes. So that y squared cannot come out. And what's left? 5 times 2y is 10y. 5 times 2 is 10. Cube root of 9y squared. Not like, that's as far as we can go. Alright, one more here. Now we have this whole quantity of 3 times the square root of 5 minus 2 square root of 10 that is being squared. You cannot distribute that square into the parentheses. I see it all the time. You can't do it. Don't do it. Whoops, I want to erase. So don't try. We can't because it's not a product. Okay, this is a difference. It's We're subtracting one term from another term. So you cannot distribute that exponent across sums and differences. So how do we solve something like this? Well, what does it mean for something to be squared? It means you're going to multiply it by itself. So that whole quantity in the parentheses is getting multiplied by itself. And now you can FOIL or box it out. So again, I like that box method. I'm going to stick with that. I have 3 square root of 5 minus 2 square root of 10 on one side, and the exact same thing on the other side. 3 square root of 5 times 3 square root of 5. The stuff outside the radical gets multiplied, the stuff underneath the radical gets multiplied. So 3 times 3 is 9, and 5 times 5 is 25. Yes, I know that's a perfect square. We'll reduce that in a minute. And then 3 square root of 5 times negative 2 square root of 10. 3 times negative 2 is negative 6. 5 times 10 is 50, so square root of 50. Negative 2 square root of 10 times 3 square root of 5, so we're multiplying these two now. Negative 2 times negative 3 is negative 6. 10 times 5, just 50, like before. And then lastly, negative 2 square root of 10 times negative 2 square root of 10. We do negative 2 times negative 2 to get 4, and 10 times 10 to get 100. Alright, now let's simplify what we have. We have 9 times square root of 25. 25 is a perfect square, so square root of 25 is just 5. Minus 6 square root of 50, minus 6 square root of 50, and plus 4 times 10, or square root of 100 is 10, right? That's also a perfect square. Alright, still not done. We've got some like terms here, and I'm going to multiply. 9 times 5 is 45. Negative 6 square root of 50 minus 6 square root of 50 is negative 12 square root of 50. And 4 times 10 is 40. Still not done. I can add some like terms. 45 plus 40 is 85. And then I also need to simplify my radical. So 50, we've talked about it before, is 5 times 10, which is 5 times 2. I have a perfect square. I'm going to take out the square root of 5 squared is 5. I'm left with a 2 underneath the radical. And don't forget that negative 12 that was already there. So one last step, 85 minus 12 times 5 is 60 square root 2. And there you have it. So when we're multiplying by one term, we distribute. Two terms, you can FOIL or box. Anything bigger than that, you'd want to either use distributing, just straight distributing, or box method. You need to make sure you're multiplying things under the radical together, and things outside of the radical stay outside of the radical. You are simplifying all the radicals you have and combining any like terms you have.